solve systems of equations. For example, negative 3x1 plus 2x2 equals 1, and 5x1 plus x2 equals negative 4. The goal here is to find a particular value for x1, the variable x1, and the variable x2, so that if I plug it in here and here, I get 1, and if I plug it in here and here, I get negative 4. This is this is also described as solving a system of equations. This is a system of two equations, first equation, second equation, and two unknowns. By unknowns, I mean two variables. And in this case, the variables are x1 and x2. Now, there's several ways to do this. I think coming out of, let's say, pre-calculus, most people prefer the method of substitution, or as an alternative, you also have what's called elimination. These are two different ways of doing the same thing. Generally speaking, in my experience, most people prefer this one. It's a little more intuitive. But for linear algebra, you want to learn how to do this with elimination. We do everything with elimination. But for comparison's sake, let me go ahead and do it with substitution. So if you're solving this with substitution, what I'm going to do is I'm going to pick a variable to solve for. I'm looking at the second equation here. And my idea is, let's take 5x1 plus x2 equaling negative 4, and we'll solve for x2. And if I subtract 5x1 from both sides, I have a formula for x2. What I can now do is recall my first formula, that is to say negative 3x1 plus 2 times x2, and that ought to equal 1. Now in this particular case, I have a formula for x2, so instead of writing x2, I'll substitute it with what it's equal to. So from this, you can see that by distributing, 2 times negative 4 is negative 8, 2 times negative 5 is negative 10, and since we have two like terms, I can safely say that negative 8 minus 13x1 equals 1, and if I add 8 to both sides, 1 plus 8 is 9, and this is going to come out to be a fraction, it looks like, because if I divide both sides by negative 13, I get negative 9 over 13. Now, I have not completely solved the system of equations because I need to know the values of both x1 and x2 that would make both equations true simultaneously. But now I know something I didn't know before. Now I know that if such a solution exists, x1 would have to be negative 9/13. So let's go back to our formula for x2, and I can see now that x2 is equal to negative 4 minus 5 times x1. And now I know that x1 would have to be negative 9/13. With that, it follows that negative 4 plus, since the negative times negative is a positive, and 5 times 9 is 45. And then if I get a common denominator, I believe 13 times 4 is 52, so we end up with negative 52 plus 45 over 13. And is that negative 7/13? And what's special about these two numbers is that these are the numbers that you would plug into these two equations to simultaneously get 1 in the first equation and negative 4 in the second equation. And in the next video I'll do the same problem but using elimination instead of substitution.